Okay, we'll continue with something cooler, which will be something easier to digest, I think, which will be file management. And apart from, well, learning how to do file management in Orchard, you will also kind of get a grasp of all the ideas behind Orchard's abstractions and why they are good. Because, well, managing files in .NET is easy enough. You have the system.io namespace, you have a lot of third-party packages, whatever, but we don't use those, well, we don't use those if it's not entirely necessary in Orchard, but rather we use Orchard's own file management services. To demonstrate those, I will just close everything here and create a new controller. Let this be called File Management Controller, and we will just play along in there. Well, again, this will be a controller. Oops. And, again, we will just play with everything from the debugger, so nothing fancy needed here. We will just create a void index method. Well, as you surely know, in MVC, a lot of things are convention driven, and the index action is also a convention. If you have an action called index, then, sorry, it should be, index, then it will be automatically called without specifying the action name in the route actually. So just /file management and it will open up the index action. Now, what do we use for file management in Orchard? Again, we will use services, but a service that we haven't seen yet. So I will do some ctor inject again to inject that service into this controller. And this service will be the storage provider. Now let's put it into the field called storage provider. What's iStorage provider? iStorage provider is, well, very simply put, the system.io of Orchard. But why do we need a system.io for Orchard? Well, let's see. For example, the storage provider has methods like create file, or delete file, or create folder. Okay, but shouldn't we use system.io.file instead and directory instead? Well, no. And the reason is that the storage provider is used to access media files. So remember when we created media files from the admin? Now those media files are actually stored in the media folder. So if you take a look at the solution, and I'm now opening orchard.web, and the media folder there, because we have a media folder, and the default folder there, because, well, we are on the default tenant, but we haven't looked into tenant yet. Here we have our meerkats. All of these files were created, and all of these files are managed via the storage provider. Now we could also say that, all right, I will use the file class to create files in this same folder, and that's cool, right? Well, no. The reason is that the media folder is for public files, public media files. And how we store those public media files can very much depend on the use case and on the environment. During local development like here, we of course store these files just on the local file system because that's the easiest way to do that. But once we deploy to a production environment, for example to the Microsoft Azure cloud, then we might not use the local file system at all for such media files. In Azure, on our own websites and on a lot of other Azure deployed Orchard websites, Azure Blob Storage is used, which is a storage for static files. It's very good at that, and files are directly served from that blob storage. So when you are using blob storage in Azure, you are not storing media files on the web server, but rather in a remote service. You just push files there, and then you request public URLs from there as well. The good thing with the storage provider is, and with any such kind of abstraction, that you use a service and code against that service without knowing what the actual implementation will be in the end. So I can say storage provider.create file here to create a file, and regardless of this code running locally with a local media folder, or in Azure with a blob storage media folder, or in Amazon with a Amazon whatever, it will still work, and it will still work the same. So let's create a file, but first let's come up with a path for it. It could be a simple file name like not meerkat this time, val.txt, or it could be a path including a folder name. So we could use a file name or a complete path, like for example demo/.meerkat.txt. So let this be our file path, and we will work with this file from now on. Well, first we need to create a file to do anything with it, obviously. So the create file method looks good, and it just needs a path. But it returns an iStorage file, which iStorage file has, well, several methods. Well, getPath won't be interesting, getName either. GetSize, we know that it's 0 at this time. Last updated file type aren't too interesting either. But we have an OpenRead, OpenWrite, and create file. So what are these? As you can see, all of these methods operate on streams. If you are not familiar with streams, in .NET, streams are kind of the high-level abstraction of interacting with chunks of data. Let's say it like that. Basically, streams are, well, streams of bytes or a series of bytes that you can rewrite, modify, whatever. There can be memory streams, so data stored in memory, or file streams, for example. And in this case, we don't know what's actually in the background, because iStorage file is just an interface. But we know that file management will be implemented with streams in the background. And that's good, because pretty much every API out there that manages files allows you to use streams, and it's not too complicated to interact with streams. So it's a good common lowest denominator. Okay, so now that we have a file, let's open it for writing. But this will give us a stream, and the stream is a disposable, so we better use the using construct. So, well, let's create a stream, which will be the write stream of this file. And what can we do here? Well, let's see. Stream, and there is, well, there's write async, write byte, blah, blah, blah. The issue is that the write method needs a byte array as a buffer, and an offset, and a count, so it's pretty arcane. We need to do something, we need something better. And actually, there is something better. And the something better is called Streamwriter. Well, a Streamwriter is shockingly an object to write data into streams, but in a more convenient way. That's still standard.NET what I'm doing here. And the Streamwriter is a disposable as well, so I'm adding an embedded using construct here. And I'm creating a new Streamwriter here using this existing stream. And now we should be able to do some cool stuff, like we have a lot of write overloads with boolean, character, blah, 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 and also string. So this is probably the easiest one to use. We can just write anything here. And that's it. If everything goes all right, now we should have, once I hit Ctrl-Shift-S and open this file management controller, we should get a file. So let's open the controller. Again, dynamic compilation, so we'll need to wait a few seconds. Okay, nothing happened, and that's good because, again, our index method is void. So let's take at the media folder now. Still, we are in the default folder, and now we have a demo folder as well. That's new. And inside we have a txt file, and inside we have hello world. So it worked. And furthermore, an update package is available for Notepad++. Benedict likes the update package.
My favorite kind of
Yeah. So let's see what happens when we do a refresh here. There is something bad. Well, we could look into it, but actually what's bad there is that the file already exists, so we can't create the file. And that means that probably we should add some check, so we can hit F5 on this page indefinitely, because obviously that's what we want to do. So instead of just creating the file, let's create the file conditionally if it doesn't exist. So I'm wrapping this into an if, and let's check whether the file exists. Again, I'm using the same file path, and if it exists, we'll create it. What's returned here is an iStorage file, so again, I'm factoring this file variable out here, so you can use it also in the outer block. Sorry, if the file doesn't exist, then we need to create it, and if it exists, well, then we will open it. Well, not open it, but get it. Yeah, probably open would be the better verb here. And now it should work. Let's actually add a date to this string so we can see that it works. Well, not here, but no, we haven't seen yet. But there is also a service for the clock in Orchard. Now you are probably asking, why do I need a service for the clock? And the answer is what you will get in a minute, but first I will inject it so we can see. The service for the clock in Orchard is called iClock. So you can inject it just as any service. Oops. And it's quite simple. But it's also a volatile provider, which is something very magic. We won't go into that. But the main point is that it has a UTC now property. So we can actually get the time from this clock. Oops. Like this even. But why don't we simply write datetime.utc now? The reason is that if we use such static classes, static properties, or even static methods from .NET types like that, then that won't be testable. So if you would write a test, an automated test, even a unit test for this index method, then the time would be the actual time, because it would actually come from .NET. Now, since we are using this iClock service, we could actually mock this iClock, supply a different implementation, for example, one that always returns the same time. So in our test, we can reliably test against the code, and the logic will execute the same regardless of the time, because otherwise it would just probably do something different, like this code here, and we couldn't, we would have a harder time writing a proper test for that. So let's see what happens now. I'm refreshing this this action, and what we await here is that it will work. Yes. So let's go back to our txt, and as we can see, it works. We have the current UTC time here. Let's do a refresh again. Okay, it's not reloading, so I mean, let's do a refresh. And now it's different. The date is different, so it indeed works. That's good. Now, the storage provider is not too complicated service, so feel free to explore it. There are other methods like, well, obviously delete file and delete folder, which I presume you will find out what it does. There is also rename. There is also read all text, just as in system.io. So pretty much everything. The main point here is that if you want to manage media files from your module, let those be media files that users can upload via the media library module, or files that are completely just handled by your module alone, use iStorage provider. This will make sure that your module works in any scenario, in any environment, and well, it's good. Yeah, by the way, one last thing, we have seen file.openWrite. Obviously, if you want to read the file, you will need file.openRead, and that's it. But you will need a stream reader instead of the Streamwriter to read the string.